Hello, and welcome to our mini lecture on nuclear decay from Chemistry 1412. A nuclide is a single atom, perhaps not the most stable of that element. Some nuclides are so unstable that they will decay. This can mean that one element turns into a different element. This type of reaction is not technically chemistry, it's physics. Let's learn more. Nuclei hold protons and neutrons. They are both called nucleons. A nuclide is a distinct atom characterized by an atomic number and a mass number. Here we see the nuclide symbols for three atoms, two of which are isotopes of each other. Sometimes nuclei are unstable. These nuclei emit radiation and are radioactive. Remember that protons and neutrons are found in the nucleus of atoms. Nuclei are extremely dense. The nucleons are packed very tightly together in a very small volume. Protons repel one another despite the shielding cushion of neutrons. Sometimes the repulsions are so great that the nucleus will decay. When a nucleus decays, it can eject protons, neutrons, beta particles, and more. Because radioactive decay can often change one element into a different element, the way that we balance them is different from chemical reactions. It is more similar to balancing redox reactions, but instead of balancing mass by balancing the elements on each side, you balance the mass by balancing the mass numbers. And instead of balancing charge by adding electrons, you balance the atomic numbers. In short, you balance the top numbers in the nuclide symbols and you balance the bottom numbers. Then you can assign element symbols based on the atomic numbers. There are three types of radiation: alpha, beta, and gamma. Alpha particles have a positive charge, so they are attracted to a negative electric field. Beta particles have a negative charge, so they are attracted to a positive electric field. Gamma particles have no charge, so they are unaffected by an electric field. We shall look at each of the three types of radiation separately. Alpha particles are simply helium nuclei which are emitted from inside a nucleus. Large nuclei that are unstable typically undergo alpha radiation in order to become more stable. Polonium-210 is a common example of a nucleus that undergoes alpha decay. It is a favorite of the Kremlin. They use it to poison and kill dissidents. Beta particles are electrons which are emitted from inside a nucleus. Typically, nuclides undergo beta decay when there is an imbalance in the ratio of neutrons to protons. Carbon-14 is a common example of a nuclide which undergoes beta decay. Carbon-14 radioactive dating is a technique used by archaeologists to establish the age of fossils. Gamma radiation is pure energy which is released from an excited nucleus. There are many reasons for nuclides to be in an excited state. Nucleosynthesis, which occurs in the interior of stars, produces excited nuclides, as do nuclear chemistry experiments conducted here on Earth in particle accelerators and colliders. Gamma radiation has no charge and no mass. It is able to pass through materials very easily. Other types of nuclear reactions are positron emission, which is analogous to beta decay except that the particle is the antimatter particle of an electron. Electron capture, which is when a nucleus reaches out and ingests an inner orbital electron, combining it with a proton to create a neutron inside the nucleus. And transmutation, which is the bombardment of a nucleus with other atoms to create larger atoms. This is how new elements are created in the laboratory. This has been your mini lecture on nuclear decay from our Chemistry 1412 class. Please go to Sapling now and do any related assignments. If you get stuck and need help, please do not hesitate to ask. I am happy to help.